Hello dear students, welcome to Teja my YouTube channel. So I have started a new series of videos in which I am going to solve topic wise questions and explain the answers in detail so that it will help you for your Kcet upcoming Kcet examination, which is going to be conducted in 2026. So try to utilize it if it is useful, and if you find it is useful, refer your friends also. So without a delay, let us start with a first topic, that is Coulomb's law. So what does the Coulomb's law tells? According to Coulomb's law, the electrostatic force of attraction and repulsion between two stationary point charges is directly proportional to the product of the charges, and it should be the magnitude of product of the charges, and it is inversely proportional to square of the distance between them. So if I consider 2 point charges here, so that is charge q1, charge q2, they are separated by some distance. How much is that? Let's consider that is r. So there will be force of attraction between these two. So that depends on three factors. One is force is directly proportional to magnitude of product of the charges and inversely proportional to square of the distance between them. So two factors are done, like one is charge, second one is distance. What is the third factor? So I will tell that if you remove the proportionality sign, you will get a constant called 1 divided by 4 pi epsilon naught into k into q1 q2 by r square, that is magnitude of charges, where k is called dielectric constant. That means the medium which is present here. So if it is air medium, for air medium, so k value is 1, where k is dielectric constant. Dielectric constant for air or vacuum. So then what is the value of 1 by 4 of epsilon naught, where 1 divided by 4 pi epsilon naught is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. So this is the first topic, so based on which I am going to solve few questions. So let us start with the first question that we have here. The first question which we have here is 2 point charges separated by distance d repel each other with a force 9 Newton. If the separation between them becomes 3d, if d becomes 3d, the force of repulsion will be. So let us solve this, where the topic that we have to use is Coulomb's law. So F is equal to 1 over 4 pi epsilon naught q1 q2 divided by r square, where I have taken k value as 1 because here medium is not mentioned. I'll consider it as air medium. So now, so initially when the distance between the charges is small d, okay, so then the force is given by 9 newtons. So case 1, 9 newtons is equal to 1 by 4 of epsilon naught is a constant, you can write it as k also, or c. So q1 q2 is not given, 2 point charges is given, q1 q2 divided by d square. Now what if this distance becomes 3d? If d becomes 3d, so what happens here is f dash is equal to 1 over 4 pi epsilon naught q1 q2 divided by 3d square. So f dash is equal to 1 over 4 pi epsilon naught q1 q2 divided by 9d square. Here 1 by 4 pi epsilon naught q1 q2 by d square value is 9d. So here this part is this. So I'll substitute 9 there. So f dash becomes 9 newtons divided by 9 will give you 1 newton. So that's why the new force will become 1 newton. So the answer is A. The correct answer is A, that is 1 newton. So I'll move on to the next question. Here we have two positive ions, each carrying a charge q, are separated by distance small d. If capital F is the force of repulsion between the ions, the number of electrons missing from each ion will be. So here two positive ions are given. Let me consider this is one positive ion, q. So the charge is same. Charge is given small q. They are separated by some distance, small d. If capital F is the force of repulsion between them, that is F is equal to 1 over 4 pi epsilon naught. Q1 is q, q2 is q divided by d square. So what we have to find here is, we need to find out n value. We know that from quantization of charges, we have q is equal to n into e. Therefore F is equal to 1 over 4. Instead of writing every time 1 by 4 pi epsilon naught, I will write it as some constant k. So q is ne, another q is ne divided by d square. Okay, so we need to find out n value. So F is equal to k n square e square divided by d square. Therefore n square is equal to F into d square divided by k into e square. So n is equal to square root of F d square divided by k e square, or you can substitute the value of k. So k value is n is equal to F into k value is 1 by 4 pi epsilon naught. 4 pi epsilon naught will come to the numerator because k is in denominator. D square divided by e square under the root. So in which option do we have this? That is under the root we have B and C. So I think C is correct answer. Okay, moving on to the next question. 4 charges are placed at the corners of square ABCD as shown in the figure. The force on the charge kept at O is. So if you consider the diagram here, here we have negative charge, here we have positive charge, here plus q, here plus q. So force due to plus q and plus q will be, so if it is a positive charge, so the force will be repulsive force. O, the charge placed at O is what? It is not mentioned, right? So maybe it is negative or positive charge. Let's consider it is a positive charge. If it is a positive charge, the force due to charge at C is opposite to force due to charge at A. So they get cancelled. FA is equal to FC get cancelled. But if you consider here, due to negative charge, the force will be attractive. Due to positive charge, that is 2A, the force will be repulsive. So that results in the moment of charge O in this particular direction, that is BD. Therefore, the charge moves in which direction? Along the diagonal BD. So option B is correct. Along the diagonal BD. Okay, na? Moving on to the next question. charges 4q, small q and capital Q are placed along x-axis at position x is equal to 0, x is equal to L by 2 and x is equal to L respectively. Find the value of small q so that the force on the capital Q charge is 0. Let me draw the diagram for that. I will consider x-axis like this. Okay, so at x is equal to 0 we have a charge. At x is equal to L by 2 we have one charge. At x is equal to L we have another charge, that is 4q, small q and capital Q. Find the value of q, that is small q is equal to how much, so that the force on capital Q is 0. The force on capital Q is because of 4q and small q. For example, if this force capital Q is experiencing force, it should be experiencing net force which is equal to 0. Since 4q and q are like charges, so there will be repulsive force. Force due to 4q and small q is repulsive force. To balance that, small q should be acting force in the opposite direction, force due to small q. So from the given data, F4q must be equal to F small q. So that gives some constant k 1 by 4 of epsilon naught 4q into capital Q. The force between 4q and capital Q is given by this formula. What is the distance? L square, which is equal to force between small q and capital Q. 4q and capital Q, small q and capital Q is k 4q, capital Q is done, small q into capital Q divided by distance between them is L by 2 whole square. So now k get cancelled, L square get cancelled, one small q capital Q get cancelled. So 4q is equal to 2 to the 4 into small q. So you will get q is equal to capital Q, but this is negative. Correct? No? Any doubt in this? L 2 to the 4 get cancelled. So you will get q is equal to capital Q. The magnitude is q, but if you consider small q in polarity, it should be minus q. Why? Because they should attract each other. This force is attractive force. So one should be positive, one should be negative. If I consider capital Q is positive, small q should be negative. That's why we consider it as minus q. So which option is correct? Option D is correct. Okay. Now let us move to the next question. 4 charges as shown in the figure are placed at the corners of a square of side A. What is the ratio of capital Q by small q if the net force on the capital Q is 0? So let us solve this question. Here if you consider the net force acting on the capital Q is 0, then you may have to consider the consideration like the force acting on capital Q due to small q, let's consider in this direction, is F Q into capital Q, and to balance that, small q charges experience force in the opposite direction like this. So that is force due to small q on capital Q, force due to small q on capital Q. So I'll consider this as F1, F2 and F3, where F1 and F2 will be same forces, but F3, for that you need to calculate this distance, that will be so square root of 2a square, that is root 2 into a, the distance. So if I use Coulomb's law here, what do I get? Let us solve this. So f1 is equal to f2, which is equal to kq by a square, but f3 is equal to kq square by root 2a whole square, that is 2a square. Okay, now the net force acting on the what is this charge capital Q should be 0. So if you find the resultant force between f1 and f2, this angle will be 90 degree. F is equal to square root of f1 square plus f2 square, that is equal to kq capital Q divided by a square plus kq capital Q divided by a square whole square is there under the root, that is equal to root 2 times kq capital Q divided by a square. This is the resultant force for f1 and f2. So that resultant force will be acting diagonally in this direction, that is f. So f is equal to f3. If you equate, what do you get? F is equal to f3. Since f is equal to root 2 k q capital Q divided by a square, which is equal to f3 is k q square by 2a square. So what get cancelled here? K get cancelled, capital Q1 capital Q get cancelled, a square get cancelled. So we'll be having, they are asking us to find out the capital Q by small q. So we'll get root 2 capital Q is equal to capital Q by 2. So capital Q divided by small q is 2 root 2. But we know that capital Q and small q are having different polarity. So the magnitude is this much, but capital Q by small q of different polarity will be minus 2 root 2. That's why option B is correct. The correct answer is option B, that is minus 2 root 2. Let us move on to the next question. Three equal charges are placed on three corners of a square. If the force between Q1 and Q2 is F12 and that between Q1 and Q3 is F13, the ratio of F12 to F13 is. So here it is similar to the previous question. If you consider a square and keep three charges, three equal charges, so that is Q1, Q2, Q3 is given. Let me consider it as Q, Q, Q. If the force between Q1 and Q2 is F12, that means the force between 1 and 2 is F12, and the force between Q1 and Q3 is F13. Here between diagonally opposite charges is F13. Then the ratio of F12 and F13 is F12 is given by K Q1 Q2. Like since they have given three equal charges, I will take QQ divided by distance. Let me consider it as A square. For F13, diagonal length is root 2A, that is F13 is equal to K QQ divided by root 2A whole square, that is 2A whole square, 2A square. So if we divide these two, F12 divided by F13 is equal to K Q divided by A square divided by K Q divided by 2A square. So that's why we'll get 2 as the answer. Option B is correct. So this is about the first 6 questions in this. I'm going to do one more video on this topic, that I will do in the next video. We'll meet you in the next video. Till then, take care. Bye bye. Keep practicing. Rock well.